Russ is probably the best demo guy that I've got. He does all the analyst demos for me. And you know, when you see his boss, Tim, just don't tell him that I use him a lot for sort of demos because he's, you know, an extraordinary product manager. And the other thing that you don't know about him, or I doubt you know about him, is he's just had a baby. Congratulations.
All right.
Now you can go do your talk. How about that?
Yeah, great. Now I'll do my talk that does not actually have a demo in it with that lead up. But thank you, Mark.
Okay, so now we'll move right on to world sensing. Oh, no, sorry.
Yes, hello, everybody. My name is Russ Savage. As Mark said, I'm a product manager at InfluxData, and I'm happy to be here to talk to you guys about monitoring, alerting, and tasks as code in 2.0. Before I get started, I feel like I'm flanked on either sides by these shadows, so it's kind of freaky here. But yeah, we're going to walk through a couple things. So touch on and connect with what Paul kind of mentioned earlier today, and Tim touched on, but this interactive versus autonomous monitoring. I'm going to talk a little bit about InfluxDB and tasks. Introduce what those are and how they can be useful, and hopefully how you guys can leverage them in what you're building. I'm going to talk a little bit about tasks as code and some of the features and some of the components that we've used to enable developers to write less code and get started quickly. And then I'm going to show a little bit of the alerting and notifications preview. It's still in design. I've got some mocks and some API design that I'd like to share with you guys and tell you how to learn more about how we progress and how we build that out. And then I'm going to touch on a little bit about capacitor and what's next for capacitor in the alerting and notifications world. So I know it looks like a lot to cover, but I promise we'll get through it and hopefully get you out of here on time. Now, I know what you guys are thinking, this really cheap conference, reusing the same slides with multiple presenters, how lame. But no, we added this slide on purpose, Tim and I, to kind of talk about, make the connection between the things that Tim talked about, where we're talking about manual queries and dashboards and more of the interactive monitoring. I'm sitting there, I'm watching, I'm running, I'm executing my queries. And I want to talk a little bit more about how you can take that and kind of move towards the autonomous monitoring side of the scale, where things are happening behind the scenes and monitoring for you while you're sleeping and only alerting when you need to. Now, obviously, alerts and notifications, it's not groundbreaking. You guys all had alerts and notifications. But I really want to talk about how that kind of fits into the story of our next generation platform and 2.0. And the way that fits is through tasks, right? So I think Paul mentioned this a little bit, what tasks are. But really the tasks allow the power of Flux for continual processing and analysis of your data, right? So you build out a Flux query. The Flux query manipulates your data, enriches it, it turns it into something useful, it connects it with other data sources. How do I continuously run that process behind the scenes and make sure that my data is constantly getting updated? And that's really what tasks allow you to do. So some of the common use cases that we see with tasks, or we envision with tasks, so data rollups, right? So data rollups, big component of the 1.x line. In the 2.x world, we want you to use tasks for doing data rollups. So in this example, and I know that any of the Flux developers here will probably cringe at my terrible Flux code, but this is what a product manager was able to come up with. So in this example, I'm rolling up my CPU usage user by an hour. And you can see it looks very similar to all the other Flux scripts that you've seen today, with a little bit of change that we'll talk about a little later. But these will replace continuous queries or capacitor tick scripts for data rollups. And the nice thing is that the full capabilities of Flux are kind of at your fingertips when you're building out these tasks. Other use cases that we see, data cleansing and enrichment. If anybody's ever worked in a system where the data that's coming in isn't 100% reliable, right? Either it's a bad sensor, or it's a bad user, or it's a bad, who knows, somewhere in between. Data cleansing and enrichment can be really really useful when you're bringing in data into the system, right? And Flux allows you to combine and transform data and run additional calculations as needed. And the other thing that we'll talk about a little bit later, more in detail, is alerting and notifications. So if you think about what an alert is, it's continuously looking at data coming into the system, running some analysis on there, and then triggering a notification. And we'll talk about how tasks can do that for looking for anomalies. So some of the other components that are useful about tasks that we wanted to maintain. So tasks are self-contained, right? So the idea here is that when you write a task, you have everything you need to execute that task within the task itself, right? And that means that the tasks that you write are portable and can be imported and exported. And we've built UIs to import and export those tasks. The options included at the top of every task. So you'll notice that it's obviously got a name, it's got an every. You can also use the cron syntax, right, if you want to schedule tasks to using cron, which might be a little more familiar. I've mentioned this before, but tasks are written in the Flux language. I think people have asked this, but capacitor and tick scripts. I personally have tried to debug tick scripts using capacitor with mixed results. I've said it's not as easy as it could be. But tasks are written in the Flux language, which means that it's the exact same Flux query on the left as it is on the right. My left, your right, my left. It's got the additional options syntax that gives tasks a little bit more information about what it's supposed to do and how often it's supposed to run and what its name is, things like that. And then at the very bottom, it's got a to function, right? So in this case, this task is actually aggregating the data and then sending it to another bucket. That to function, as you saw maybe in Paul's presentation, could be sending an email, could be sending it to an external system, could be sending it to another organization, really anywhere, maybe to a notification, for example. But the nice thing about the tasks being written in the Flux language is that we don't have to write two sets of tools in order to debug and look at the tasks, right? So when you're building out tasks, the way that you build them, you can use our data explorer. You can see the exact results of your query and exact results of what your task is going to actually do. And then you can hit save as, right? And when you save as, it just adds that additional information at the top and gives you a location to send the data to. And you don't have to have a separate set of tools and a separate set of experiences for debugging. So that can be really useful. The nice thing is you don't have to learn another language, right? So when you're investing in learning Flux and you're really excited about the power of Flux, it'd be really, really terrible experience if we then told you, oh, but now you have to learn something else in order to really leverage the power of it behind the scenes. So really useful and really, really valuable that it's in the same Flux language. The other nice thing is as Flux gets more powerful, as the package manager gets deployed, and as we get more contributions in the language and more functions, all of those functions and capabilities become available for offline or task processing. So it's only going to get more powerful over time, which is awesome. So just a quick overview of tasks, kind of what we talked about, right? So again, just pounding this home. Tasks are written using Flux, which is really, really powerful. Data rollups, data cleansing, enrichment, alerting, all possible use cases. There's probably a lot more use cases that we don't know about that will be coming in the future as Flux grows. They're completely self-contained. They're portable. You can import, you can export them, you can share them. And I'll talk a little bit more about how that works a little bit later. And you can leverage the same Flux tools that you already have that you use for writing queries. You can leverage those tools for debugging and building tasks, which is really useful. So now that I've rambled on a little bit about what tasks are and how they can be used, let's talk a little bit more about tasks as code, right? So I've got this quote up here. Paul didn't exactly say this morning in his talk. I was really trying to bait him. So I want developers to write less code, and when they write code, it should be critical to their applications. So probably Paul Dix at some point in his life said something similar to this, and I'm quoting it. But really want to talk about how tasks can be managed by as code, right? So in 2.0, one of the biggest components of it is a single unified API across all the different variations of 2.0, right? Whether it's running OSS or it's running in cloud or it's running in enterprise, it's all using the same APIs, which means that everything we do is API first. And so tasks are no different. Tasks can be managed completely by the API, right? So if you're the kind of person, which I know a lot of you are, who like to build and connect directly to the APIs and automatically load tasks or interact with it that way, you hate using web browsers and UIs, you can do that via the API. So as Tim mentioned a little earlier, all of our APIs are documented in Swagger. And that's available in a swagger.yaml file that's in our repo, or when you're actually using the application, you spin it up and /docs will give you this interactive API explorer. So take a look. You can view what you can do with tasks via the API or any of the other resources in our system. For those of you that you like the API access, but you don't really want to worry about all the HTTP response codes and all that sort of stuff, tasks can be managed via the command line, right? So if your whole system, like many systems, are kind of glued together using a bunch of scripts behind the scenes, whether it's Python or God forbid Bash scripting, all of these can be managed via the CLI. So if you look at just the influx command help task, you see you can create, delete, find, log, run, update. All those components are available there. So you can build that into automated deployment scripts. You can build that into CI scripts. Anything you'd like. And I will say, as I'm talking about all of these different pieces, 2.0 is still in alpha. Right? So we're still evolving. As Paul said, we're on alpha 11. I'm hoping, if I'm slacking the engineers after this, that we're going to release alpha 12 this week. So iterative improvements as we go, but it's still a long way to go until production, right? So we really want your feedback. If you're using these CLI tools and they suck, or they don't meet your need, or you really want to see XYZ feature, please file a feature request. Please reach out to us somehow. This stuff doesn't work without your feedback and your interaction. So same with API, same with everything we're talking about today. The other part of tasks is kind of the debugging and seeing exactly what's happening, right? So tasks are running behind the scenes in your system. How do I know they're running? How do I know what's going on? So each task, every time it executes, it logs a specific run with a specific run ID that's queryable. And then that run also has a specific set of logs attached to it, right? And so if you're logging in, you want to see exactly what a task is doing. In the UI, you can click on and see all of their task runs, and you can view the logs for that task as well. So if something fails, you can see what went wrong. You can see and verify that yes, this is actually running every 1 day. So sleep a little better at night knowing that things are executing. And yeah, these run logs can be really invaluable for debugging or trying to figure out what's going on. Once you have something that's running and working as a Flux query, if then you put it as a task and something goes wrong or it can't write to a bucket or something like that, you'll be able to see it in these logs. I already mentioned this a little bit, but tasks can be shared easily. And so, in the UI, we have an export button or a download button that will download the task as an actual Flux file. that you can then take and share. And I will say that a lot of these components are really really depend on what type of Flux script you're writing, right? So if I'm out there and I'm building a task that I want to be shared, right? I might format my Flux script a little differently. I might put variables that I'm using obviously at the very top of the file, make it really easy for people to edit and make changes to. So the style of Flux script might be a little different if you're intending to share this with the rest of your company. But once you have that, that can be shared via the UI, the API, same ways. The other cool thing, and this is something that Tim touched on a little bit, but I want to double down on, is this idea of templates, right? And so in 2.0, what we've decided, or what we've built, is a templating system for all of the resources that you build yourselves, right? Templating systems are not new. We're not revolutionary here. But what's really useful for templates is it gives you a place to start. It gives your users a place to start, and it gives you a common pattern for building out anything in the system. So dashboards, tasks. In the future, it'll be basically every user-created resource. You'll be able to create a template of that resource. And then instantiating that template will then allow your users to then customize and go further, right? And so our goal is to give you a starting point and then allow you to customize as it goes. So users don't have to start from scratch. So today these templates are we have a set of templates that are going to be baked in. These are our user-defined or our system-defined templates that we ship. You can actually create a template from any of the resources that you build, and then in the future, these templates will be populated by a package repo or a third-party repo, whether it's set by us as a public one or configured by you for your organization. Also coming soon is this idea of version templates. So one of the biggest requests we've had in the system is, okay, how do I make sure that if I make a change to something, that my users are actually getting notified, or I'm able to progress and upgrade through the system? And so templates are going to be a way to do that. So the idea being, your templates will be stored in some repository, some version control, right? As you make changes to your templates and deploy those into your system, anybody who's created a dashboard or a task from that template will have the option to upgrade using your newer version, right? And so they won't be required to upgrade, but the idea is to give them the possibility to actually get the changes that you've kind of built in. So if you think about how this might work with tasks, I've built out these awesome alerts, or I've built out these awesome data processing scripts, but there was a bug. Not that there's bugs, but there was a bug. I made a new version for my template, and I deployed it in the system, and now I can ask my users, okay, if you're using this version of this template, upgrade so you get the bug fix, right? So they'll be able to see that. And the goal is this is going to apply to all templates, right? So task templates, but also dashboard and any other templates we create in the system. So again, making sure that that we don't want you to start from an empty screen every time you create a task. We want you to start from a template, whether it's defined by us or defined by you. So that gives you a little bit of guidance on how to build these tasks and how to get value out of the system. So in summary, tasks as code. They can be managed via the API and the command line. Take them for a spin, see what you think. If there's something you want to do and you can't, let's hear about it. If there's something that you can do but it's really hard, I'd love to hear about it so we can improve. They're self-contained. They can be exported and imported easily. The run history and the logs, they help with debugging and troubleshooting. You can use the same tools you use for Flux to debug tasks, as we mentioned before. And templates in 2.0 foster code reuse, and they're going to be versioned coming soon. Cool. You guys are a riveted audience, I can tell out there. Now we're getting to the exciting part, the alerts and notifications, right? This revolutionary concept of alerting and notifications, but I want to talk a little bit about how they're going to be implemented in InfluxDB 2 and what they're going to look like and how you can follow along. So coming soon, alerts and notifications. So what I've talked about kind of before, right? So we have Flux as one of the key components of 2.0 platform. It's the key component. It kind of runs through everything we do. We have tasks, which allow you to take interactive Flux queries and schedule them and run them behind the scenes. And using these two components as a foundation, we can build on top of that alerts and notifications. And so just like everything else, the API comes first. So we're going to be building out the alerting and notification API, and then build user interfaces on top of that, both through the browser and the CLI. And how you can stay involved and how you can see what's going on. I'm a product manager. I spend a lot of time in GitHub. GitHub is great for many things. It's really horrible for tracking progress over an epic. So we've defaulted to using some labels in there. So check out the epic alerts and notifications in the InfluxDB repo. As we create more issues and as that grows, you'll see more things tagged with that tag, and you can follow it there. So what's this actually going to look like? So initially, our goal is to support 3 different notification channels, right? So HTTP is kind of the fallback. The idea is you can post messages to anywhere, anybody that has an HTTP endpoint. We also want to support Slack and PagerDuty. It's a little bit selfish because those are the tools that we use internally, but it's also the tools that many DevOps teams use as well. We want to bring in threshold and deadman alerts. Those are the two style of alerts we want to start with. And you think about what are the conditions that, or what are the components that make up an alert, right? So alerts are defined as a base query, right? And that base query is going to be Flux. And so that means that anything you can do in Flux, any data manipulation you can do, any joins, anything you can think of to actually get to specific values that you want to look at, you can define in that Flux query. You define a set of threshold criteria. These are the things like, if it's above 80%, you warn. If it's above 90%, you page, that type of thing. I think Alexander had said it really well earlier today. Those conditions are not going to be rigid, right? They may start off as 80 and 90, but eventually they'll be defined as a specific average or almost like a mini Flux query in order to define what that value is. So you can do things like moving averages, things like anomaly detection, and you don't have to define a specific value. You'll have the actual notification channel that you want to send to, and this mock here from our design team is an example of defining one of those channels directly as you're building out the alert. And then you'll have metadata, right? And so that metadata for us and for our UI application is going to be things like dashboard and cell and potentially information about the user that created it. But for your custom application, you can add specific metadata that's interesting to you, and that'll be returned to you as part of the alert. So you can connect it to other components in the system. I got a couple more mocks of kind of how this is going to flow. So one of the things that we've done is really, you've seen over the past couple months, we've really the exploring experience and the cell editing experience are very similar, and that's on purpose. They use the same components behind the scenes, and we're going to insert an alerting panel into our cell editor. It'll be available in the Data Explorer if you don't want to create a cell or don't want to create a dashboard behind the scenes. We've seen a lot of people and that really enjoy connecting alerts to specific graphs in their dashboard and seeing that information. So we made it available there as well. And you'll be able to define a rule Whether it's an alert builder, you'll notice that there's a specific script editor here. So if you're a superpower user like Nathaniel and you want to come in and write your own custom Flux query to do all of your alerting, you can. You'll say when it's going to run, the type, threshold, or deadman, and you'll start putting in those thresholds, right? And initially, it'll be a fixed value, but again, just getting in those variable thresholds would be really useful. You'll define where the data is sent and what the message is actually going to look like. Again, these are mocks; these are evolving, and as we start iterating and building this, we love to get it out there. You'll see it in one of the alphas, and then from there, every alpha you'll see iterations on top of that and making it better. Just a quick, and because this is kind of a more technical audience, kind of an API mock that we put together at a high level, and again, just very, very high level. But the idea is when you define an alert, you define the query, you define the configuration, whether it's threshold or deadman, and the specific conditions for those alerts to trigger, how often it's checked. Potentially an offset if you want to wait and have some sort of delay in checking, whether it's active or inactive, so you can enable or disable alerts when you're doing triage, and then specific notification criteria. There's going to be multiple notifications, right? So you'll be able to have a bunch of different notifications for specific criteria. So you can send it to different channels based on if it's a warning or an error or a critical. And then specific metadata for your application. The notification channels are going to be defined separately. So you'll be able to define very similar to capacitor today if you've used that, but you'll be able to define the notification endpoints and then leverage those in the alerting configuration. So that's kind of a quick overview of kind of our ideas behind alerting and notifications that will be coming soon in the UI and the API. Like I said, follow the Epic alerts and notifications in GitHub if you want to get involved and comment and give feedback on those components as they come out. And as always, download the latest alpha, keep trying this out, and see if it works for you. Now I want to switch gears just a little bit. I know we don't have too many capacitor users in the audience, but capacitor is really, really powerful and is used and loved by many thousands of people. So I want to talk a little bit about the roadmap and what capacitor 1.6 is going to look like. So the goal here is really to enable a path for capacitor users to continue to leverage the investment that they've had in capacitor in the 2.x, right? And so we're not leaving capacitor users behind. So capacitor 1.6 will support a connection to InfluxDB 2.0 for streaming. It'll be similar to subscriptions today, but it won't be an auto join, right? And so you'll have to explicitly configure that capacitor is going to talk to InfluxDB 2. The one thing I do want to call out, we don't have on our roadmap right now the automatic conversion of tick scripts to Flux behind the scenes, and that's on purpose. It shouldn't be necessary if you can connect to the same data source and process it the same way. But if I will say that is probably it's a little bit variable. So if people start using this and having a really hard time translating to the new system, then we're going to revisit and think of ways to help out that migration. But yeah, the goal is to not have you convert your existing tick scripts. You would write net new tasks in 2.0. So just really quick, if there's one thing that you want to walk away from this talk is that I'm incredibly handsome and I had a new kid. But if there's 2 things or 3 things you want to take away from this talk, InfluxDB tasks allow developers to leverage the full power of Flux for autonomous data processing and alerting. And you can check it out today. Developers can build the creation and curation of tasks into their workflows using APIs, using command lines. You don't have to use our UI if you don't want to, and you can build it into your operational systems. It's a part of being a developer platform. Operators can use templates, foster standards and code reuse across the system. Version templates, alerts and notifications, capacitor support in InfluxDB 2 coming soon. And with that, I'm happy to, oh, look at this nice little build out here. I'm happy to answer any questions that you have. Thank you very much. All right, I saw a couple of hands in the back, starting with there.
Yeah, there was talk earlier on about draft and clockwork in relation to capacitor. I might have got my lines right, but with task and notifications and draft and clockwork, is there any correlation?
Yeah, so the question is, does this have anything to do with the giraffe viz library or the clock face component library? The only thing it would be connected to in the visualization library, you may be able to use the alerts to display annotations on top of your graph types, which would be part of the viz library. But there's no direct connection. So other than the tasks, the data that you process using tasks would be able to be visualized. But there's not much overlap there. Yep.
For continuous input and output tasks are really good, but sometimes we have the problem that, for example, data is not coming in for 2 hours, and then it comes in but fills up the database again, or even that we have a gap that is filled up 2 days later, and then we have to need the metrics as well for that data. That's sometimes with an issue that we have, or task can easily deal with that.
Yeah, that's so interesting. So he's describing a couple of use cases. One of them where data disappears for an hour or two and then comes back all at once. And then, so those type of scenarios, they're supposed to be addressed via dead man alerts. But I know in practice that can be really tricky because you don't necessarily want to get paged if the data is on its way or coming in. So I think that's something we'd have to look at more in detail for your specific use case. But the goal is, again, to have tasks and Flux be able to support a wide variety of processing and alerting use cases. And so that's definitely one we want to support and take a look at in more detail. Any other questions? Yep.
You mentioned under alerts and notifications in your example you had an interval of 1 day. Yeah? Is it a performance question? Why not put 1 minute or something?
Yeah, that was just I'm looking for examples for a presentation. So I just used 1 day as that specific example was doing temperature rollups for one of the new open weather map plugin now available in Telegraph 111. So that was just an example. So you can do it up to second granularity right now.
And the action that is performed there, would it be possible to call a task or a Flux script or something like that, or is it just for this specific purpose of getting some people on the phone or whatever?
That's interesting. So the question is would you be able to call other Flux scripts from tasks using the output? So I have to talk a little bit more detail with Nathaniel about the ability to call Flux functions from other Flux functions. But what I'll say is anything that Flux supports, tasks will support. And so I think it would be more of a kind of a best practices on what we would want people to do, right? So when you have nested or connected scripts like that, it can be tricky if you want to move them around or you make change to one. Do you have to change all the dependencies? So we definitely, it's probably possible, but we have to think whether that's best practice or if it's better to do it some other way. So, but definitely something to touch on with Nathaniel and the Flux conversations tomorrow. Yep. That's my skill, hand wavy level. That's what I do.
Reaching back to the anomaly detection discussion earlier, if you wanted to set up alerts such that the system kind of learns what normal behavior looks like and then turn it into a sort of active mode, how might you go about building something like that within this framework?
Yeah, so the question is how might you leverage something like, basically, you're almost talking like, how do I have a model that is trained on the data set that I'm using, and then leverage that model for alerting is kind of the idea, right? Is I want something that knows what the normal levels of my system are, and then automatically tells me when there's something out of the ordinary. So my default hand wavy answer to your hand wavy question. So for any sort of functions or data sets, we're gonna pass that to the Flux team. So what I imagine would happen, and again, don't quote me on this because I'm not the lead engineer on Flux, but there'd be a set of Flux functions or library components that you could leverage for building out some sort of model or some sort of understanding of your series, and then you'd be able to leverage that as a input into your task, right? And so you'd essentially say, okay, given the information that I'm seeing, if I then ask this model, is this within normal range or not? And I would append that information to my task and then alert on that output. It's not something that is possible today, but I would imagine it would be built through the use of Flux and Flux functions and then made available to tasks as part of that. Yep.
With the new Influx 2.0, it kind of feels like you're pulling everything into InfluxDB and making it kind of run under one thing.
Mm-hmm.
How do you distribute your processing over multiple machines so that I don't have to make like one giant machine and hope it never falls over?
Yeah, so the question is you're bringing all this crap into one thing. How are we going to, there's only a finite amount of memory in the world that we can put at InfluxDB. So what I'll say is the API is common. The actual processes, so for example, we run a version of Influx 2 for our cloud product. And when you're using tasks in cloud, like you're not running on a single machine, you're running on Kubernetes and a distributed taskd architecture system, right? And so just because in the open source everything is in a single binary and really easy to use, doesn't mean that you can't split out that functionality based on how the API is set up. And I'm not the super technical one, but the goal is not to have everything running on one single piece, be able to distribute that load. And when you're running 2.0 in something like Kubernetes, again, this is in the future, you'll be able to split that out into any number of pods and scale horizontally each individual component of the system. So the tasks component or the UI component or the database component will be scaled independently.
So everything's in one binary, but you don't necessarily have to use everything.
You don't have to use everything. Yeah, exactly. Yep. One more?
One more.
Okay.
Say after a software release, I want to see how many of a certain alerts were triggered. Would it be possible to query for certain scenario?
Yeah, so one of the things I didn't, so the question is after a new software release, I want to query for the number of alerts that were generated. Would that be possible? So one of the things I didn't touch on is a little bit of an under the covers detail. The way that we're building out tasks or alerting behind the scenes is that you'll have a set of alerting scripts that will write to a particular bucket or a particular location, right? And those will fire just any number of alerts. And then the second piece of that will be a notification script that will monitor that bucket for the alerts that were created and be able to make decisions on what to notify. And so if you wanted to figure out how many alerts were triggered, but you didn't necessarily want a page for every single one of them, you'd be able to write a query against that bucket and view that information.
Really quick in there, I can squeeze in. So, quick two questions. So you
Two questions. Oh,
Jeez.
with 5 subparts.
just like
Okay.
the threshold alerts you mentioned, are they based on obviously a static value? But is that over a time? So let's say a CPU spikes to 80%, comes back, I might not be interested in it. If it stays there above 70% for 2 minutes, I need to actually page someone.
Yeah, so the question is for the thresholds, are they based on a particular time range? The answer is there's kind of two parts to that, right? So in Flux, you can build out windowing functions for processing, and you can run aggregations over that window. So that's one of them. And then the second part is what I just mentioned is your notification script. It doesn't have to alert for every warn or every time it goes above a certain threshold. Your alert notification script can say, oh, well, if I've seen 5 warnings over the course of a minute, then I should probably tell someone about it because it's probably not good. So there's kind of two pieces, but yeah, the idea is you'll be able to set up a way for you to get, okay, if it stays above 80% for 5 minutes, then I get paged, right?
And quickly, last one is that obviously once you end up with, let's say, 1,000 tasks, you're doing, let's say, a failover or patching exercise,
Yeah.
you have one button say, go silent mode, do not trigger anything.
Do not trigger anything. Yeah, so the question is once I've got thousands of tasks and I'm super happy, how do I disable a notification or disable pages while I'm triaging an issue, I'm guessing. Yeah, so in that case, tasks can be inactive or active. So in that case, we probably build into the UI some way to essentially make the notification part of it. Your alerts would still fire, so we'd still want to know that during that outage we're getting alerts, but I want to silence the notification. So I just make that inactive while I'm triaging, and then afterwards I'd turn that back on.
Do you have to do it for every single notification?
Do you have to do it for every single notification? We're still in the process of building that out, but based on your question, I will say no. So I'll make sure that that's in that feature request. So thank you guys, really appreciate it, and come find me.